Our problem is not so much an energy problem, but a power problem, which means energy per time.
Electromobility is booming in Europe, and while some car makers such as Porsche, for example, haven't completely given up on the idea of also using synthetic fuels, in my eyes it's clear that battery-powered vehicles will be the dominant form of low-emission mobility in our long-term fight against climate change. If, however, we want to reach our goal of supplying not only mobility but also heat and electricity with mainly renewable energies already by 2050, we still have a lot of work to do. We have to reinvent the grid, we have to reinvent the business models, and we have to invest in research to fill some of the significant technological gaps. One of the approaches that is a perfect example of how these three aspects are relevant is the so-called bidirectional charging technology, or also mobility-to-grid systems. Mobility-to-Grid, or also sometimes as it's referred to V2G, Vehicle2Grid, not only helps to reduce the impact of mobility on climate, but it also offers some massive economic advantages. Hence, today we want to look into the exact details of V2G, M2G, bidirectional charging and intelligent charging. Welcome to the Smartery podcast, a podcast for and with the creators of the new energy world. A world in which energy will be renewable, decentralized and digital, bringing together electricity, heat and mobility. Let us show you how we will get there and who will get us there. And I'm very honored and happy to have on board for this episode Professor Dr. Göhlich from the Mobility2Grid Research Campus in Berlin. Professor Göhlich perfectly embodies the transformation of the German mobility industry, having worked in automotive in earlier stages of his career and, for example, having overseen the complete vehicle design of the Mercedes S-Class back in 2003, he now is the chairman of the board of Mobility2Grid Association. And he's also the head of the Methods of Product Development and Mechatronics Department at the Institute of Machine Design and Systems Engineering at the TU in Berlin. Welcome, Professor Göhlich. It's really a pleasure and honor to have you in my podcast.
Yeah, thank you very much for inviting me to this session here today.
First off, before we dive into the topic itself, how do you get to work every day? What kind of vehicles are you using?
Well, actually, I live very close to my office. Most of the days in this Corona situation, actually, I'm in home office, so I don't move at all. But if I move to my office, I usually take the bicycle. And since Berlin is very flat, it's just a standard bicycle, no e-power, nothing.
So you work for the Mobility2Grid Research Campus. What exactly is it that you do, and what is hidden behind the term Mobility2Grid?
Well, yeah, just as the term Mobility2Grid implies, our research is focused on the integration of electric street vehicles and decentralized local power grids. Our overall goal, our long-term goal, is really to shape the future of our mobility, make it affordable, efficient, and completely based on renewable energies. And to reach that goal, we leverage synergies between electric mobility, power, and even heat supply of our buildings.
All right, then let's talk about the technical terms here. Mobility2Grid, I also referred to Vehicle2Grid. Maybe you can let me know what exactly it is you're talking about when you talk about M2G, and also then the difference to V2G.
Okay, V2G, Vehicle2Grid, is the connection, the real connection between the vehicle and the grid, which is a physical connection to transfer electric power into the car, but also back to the car. That's the term bidirectional charging, where power can flow both ways. Mobility2Grid is one level above. That includes V2G, but it includes the complete sector. It is more that we not only talk about vehicles, we talk about fleets and the potential of sector coupling between energy and mobility.
And just to add one more term there, and sometimes also in that context, people speak of intelligent charging. Is that something different, or is it a sub-aspect?
A very good point, a very good point. Mobility2Grid implies both intelligent charging and bidirectional charging, because many potentials to connect those sectors can be already obtained when we just control the charging process, to shift charging from the morning to the mid of the day or the afternoon. There you need, of course, a connection You need information exchange between vehicle and the grid, but you do not need to take the power back from the batteries. And the last step, where you move energy back and forth from the vehicles to use batteries as a buffer, that's actually the term bidirectional charging. So we address both intelligent charging and bidirectional charging.
Just to dissect it a little bit further and slowly coming to the expert level, are there any differences between these kind of schemes in the private sector, such as maybe vehicle to home? And I guess one of the most prominent examples is Tesla's approach to it at the moment. I guess that's what you know. If you're not from the industry, that's probably what people have in mind. Or vehicle to work. And then on the other hand, the public sector.
Yes, of course. Well, in the private sector, we have to deal with individual cars, right? Privately owned. And the owner of the car remains in control when to charge the vehicle and when maybe to use the battery of the vehicle as an intelligent charging and even bidirectional charging device. When we talk about fleets, we are going into the public or industrial sector. And there, of course, it becomes very interesting, especially for the grid side, for the grid distribution service operators, because a large fleet of vehicles is a large fleet of batteries. And you have more energy and more power to work with. And that's why the idea of integrating fleets into the grid is very, very attractive. And also talking about the short-term effects, that's where we see the higher benefits. It will take somewhat longer to integrate really a fleet of millions of battery electric vehicles into the grid.
When you talk about the millions of battery-driven vehicles, then you talk about the privately owned vehicles. So let's say maybe somebody like you or me living in a suburb of Berlin, having his solar plant on the roof, charging his vehicle and being integrated into the grid.
Yes, exactly. And why is this so important? Let me illustrate this with a simple example. The electricity production in Germany must cover the power demand. And what many people ignore is that our problem is not so much an energy problem, but a power problem, which means energy per time. So our electricity production in Germany must produce power between 30 and 85 gigawatts. That's the power we need when you turn on your refrigerator or when you charge your car or whatever you do where you need electricity. So 30 to 85 gigawatts. Let's make a simple assumption. Let's assume that we have 5 million battery electric vehicles on the street. That's 10% of our car population in Germany, which is over 40 million, right? So 10% battery electric vehicles. And then we do a simple calculation. We say that 20% of these 5 million are connected to the grid simultaneously. And we assume a medium technology, so-called smart wall boxes, which you can also install at home for a few thousand euros, and you have 11 kilowatt charging facility at home. So what does it mean? When we have this number of vehicles connected with these wall boxes, we have simultaneously 11 gigawatts. And that you have to compare with the 30 to 85 gigawatts, which is total for Germany. So yes, we need additional energy. And if we can control it, we can use this 11 gigawatts to buffer fluctuations from the renewable energies. Because solar energy we have during daytime, especially at midday, not at night, and the wind may blow or not to blow. So there is a real potential for the future. And this simple calculation makes clear that we should leverage that. And of course, now to get this 5 million vehicles connected to the grid takes technology, takes smart wall boxes, takes infrastructure, takes IT. But the basic technologies we develop today and to make our system ready for the future in the next 10 years, let's say.
Before we continue, a quick shout out to our partner for this episode, which is the Mobility House, a leading technology company that is already creating the conditions for a zero-emission energy and mobility future, with its intelligent and future-proof charging solutions for electric cars. In order to realize this vision, the Mobility House collaborates with several partners within the automotive and energy industries. In particular, the company is driving forward the integration of vehicle batteries into the power grid. A current study initiated by Nissan and E.ON, for example, shows that there's an annual savings potential for the operation of the power-to-grid of around 13,500 euros per single electric car. And other projects around the world come to similar conclusions. So with your research, can you confirm these potential cost savings and Maybe you can share, if that's correct in your eyes as well, what other advantages V2G does offer.
Well, the financial potentials are there, but it depends, of course, on the local situation and on the regulations. Frankly speaking, the savings of this study seems high. And when you connect your car today to the grid in Germany, you cannot get this kind of financial advantage. But it will change in the future because, of course, today for the grid operators, the fleet is not large enough for them to really work with the batteries. For a fleet operator, the story is completely different because a fleet operator with a large fleet of vehicles, high power demand, but also the possibility to shift peaks of power during the day, they are already today a very, very interesting partner to negotiate with the power companies.
Right. So when I understood you correctly, private use of V2G and specifically like saving costs with that is more a long-term goal or potential. But right now we're already able to implement cost savings, in the fleet sector. So maybe you can share a bit more about the potentials there for fleet operators, and also maybe what is the current situation or the status quo when it comes to M2G and V2G in fleets?
Well, here in Berlin, we work, for example, with a Berlin bus operator, the BVG. They're currently in the process of transforming their fleet completely to electric buses. We have some pilot projects running, around 50 electric buses today, but at the end of the decade, they're going to have 1,700, maybe 1,800 electric buses in Berlin. That's a large fleet. Buses are large vehicles. They have large batteries, depending on the technology, between 100 kilowatt hours and maybe even 400 kilowatt hours. So we made studies to optimize the charging and the operations of electric buses. And we could show that when you do intelligent charging, only intelligent charging, not yet bidirectional, you can cut the power demand of a depot, of a bus depot, where about 200 and 300 buses are parked, from over 4 megawatts, down to maybe about 3 megawatts. And this reduction of peak power is very interesting to the grid operator, right? And you get a completely different price. When you talk to your grid operator and yes, I need a peak power, 4 megawatts or 3 megawatts, it's a different situation.
And I assume just the implementation of intelligent charging is a very low-key goal and also technologically not that difficult as then implementing the bidirectional charging.
The technology is relatively straightforward because all you need to do is turn on and off the charging station. However, the intelligence is on the planning because now you need to have the buses on the depot. You need to know when the bus's batteries need to be filled. And that's what that's one research sub-project at M2G to develop software to support this process. That the buses are ready to go whenever they need to go, but not necessarily you have to fill the batteries when they enter the depot. Maybe you have a couple of hours time, but that's not such a simple question, especially if your fleet is large. And we do not, of course, we do not want to anyway have more buses than needed or even hamper the operations of the buses. Of course, that cannot happen.
So you spoke about the example here based on BVG, the Berlin bus fleet operator. What other examples do you see across Europe? What's the status quo there? Is there like a wide implementation? Are there a lot of projects similar to this? For example, I guess airports are an interesting field to work with this technology as well. I think Stuttgart and the airport in Amsterdam have been using electromobility for quite some time and require a lot of energy. So are these fields that this technology is interesting for? And if yes, which other regions are pioneers in this regard?
Yeah, definitely. In the field of public transportation, vehicle-to-grid technologies are rapidly evolving all over Europe, in Asia, in the US. You see that in the Netherlands, for example, they have a large test center there. UK is also very much advanced in terms of e-buses and grid integration. Denmark is also a country where we have lots of electric vehicles. Airports are, of course, interesting, but as actually any point where you have a large fleet is interesting. So also car-sharing operators in the future can be an interesting partner in terms of vehicle-to-grid technologies.
I just want to slip in a short global question there. This to me sounds like as if Europe slowly is closing the gap compared to China.
Oh, definitely. Definitely, we're catching up. It's very interesting to look at China. In China, you have certain activities, certain projects where they, in a way, use brute force. Right? They just say, okay, in Shenzhen, we convert the complete fleet And they have 16,000 electric buses in Shenzhen. That's astonishing. And that's, of course, also a big advancement. But in terms of intelligence, in terms of being efficient, we are not behind China or other Asian countries. Because those brute force projects, in a way, the cost is secondary for them, right? But when we work with the BVG, we work with them under a strong cost pressure to really keep the extra cost for going from diesel to electric buses to a minimum. Today, we have to still take into account about 10-15% extra cost. But we can project that in 5 or 6 years from now, electric buses are completely competitive with diesel buses.
And when you say completely competitive, I assume you refer to all the aspects. So the acquisition of the buses, the operation and maintenance costs, as well as powering the buses. So you mentioned earlier that for private users, intelligent charging is not interesting yet, mainly because of the economy behind it and regulations. Is that the same for fleet operators, or can they already use intelligent charging to save costs today?
When you look at your fleet, when you pay your electricity bill, you pay for two things. You pay for the energy. That's the overall electricity you use over the year. But you also pay for peak power. And when you need peak power of 4 megawatts, even if you need it only 1 day per year, you have to pay much more for electricity compared to the situation you say my maximum peak power is 2 megawatts. That makes a big difference. And there, the economy is already there, and the negotiations between the electricity provider and the fleet operators, they happen today.
All right, that makes perfect sense. So for fleet operators, it's interesting today already, specifically because in regards to peak power charging. And for the private operators or participants, do you think this will change ever, somewhere in the future? And maybe what kind of year would you see? How many years until it's also interesting for private owners?
Well, it depends. It's an economy of scale, right? We need, as I pointed out, we need, for example, this 5 million battery electric vehicles. Then it makes sense. So it depends how fast is the process of transformation from fossil fuel powered cars to battery electric cars. In 2010, we had the idea, the National Platform on E-Mobility had the idea that at 2020 we have 1 million electric vehicles on the road, right? We are far behind that goal. But now the market is really picking up. And I would assume in 5 years from now, we will talk differently also about the usage of private electric vehicles in conjunction with the electricity grid.
All right, well, that's not too far in the future. And that would be 2026. And if we then put that in contrast to 2050, that just still leaves us a quarter of a century to make it a part of our big climate impact goals.
The pressure on the transportation sector is high because, as you may know, the electricity production becomes more and more green, right? More and more renewable. When you look at the transportation sector, we are still in the year 2020, not too far below the greenhouse gas emission of the 90s, right? Of course, cars got more efficient, but the overall transportation volume increased. So the transportation sector is not really progressing as we need to be for climate protection.
We're already almost at the end there, and we've heard a lot of advantages from M2G approaches. We've heard that they're very promising developments. Are there any arguments for critics of this technology? Are there any risks involved that still need to be mitigated?
Of course, we need to keep in mind that battery electric vehicles are clean only if we produce electric power based on renewable energies. So the Energiewende, transformation of our energy system, and the transformation to battery electric vehicles, really that has to work hand in hand. And so we really have to push both processes forward with all the power we have behind. Of course, there is the critique on battery electric vehicles in terms of range, this range anxiety, which is somewhat exaggerated, but still, a battery electric car cannot run for 1,000 kilometers like a diesel car. So yes, for urban transportation, for example, I see for all sectors, private, but also for buses and also for truck and delivery processes. In an urban environment, our studies show that 100% electric is possible already today or in the next years.
100% electric in an urban environment is possible today already. That's an amazing statement. I'll take that as a final statement. Thank you, Professor Göhlich. So if we look at the overall pictures and the technologies we spoke about, let me conclude in what order they'll probably be implemented in the coming years. So intelligent charging is already being implemented today with still some challenges needed to be solved. Then the next step probably will be the bidirectional charging. That then really opens completely new possibilities in regards to energy or power buffering in the grid. And you also said that the evolution will probably go from fleet operators then to privately owned vehicles, simply because it's price-wise, it's much more interesting for fleet operators now already. And also there are some necessary regulatory changes in regards to private owners, such as you said it, smart meters in private homes, etc. But it's quite interesting to hear that that will also be a part of our near future. So you said it yourself, like already maybe in 5 years, we will look at a completely different picture there. So thanks a lot, really, for dissecting today the differences between intelligent charging, bidirectional charging, mobility-to-grid and vehicle-to-grid. Thanks a lot, Professor Göhlich.
Yeah, thank you very much. I think we had a very fruitful conversation, and I hope your listeners will appreciate what we talked about.
Certainly. Thanks a lot for joining us today. Stay tuned for more episodes of the Smart EE podcast. You can also learn all about electromobility and charging infrastructure in context of the new energy world at the Power to Drive Europe conference in Munich. All information about the conference can be found online at powertodrive.de/conference.